In this class what we are going to do is the probably a continuation of this TRL, what we talk about technology readiness level, and with some example of as it has been applied to a well known process, because till now we had been talking only about the concept of TRL 1 2 3 4. It is always nice to relate it to an existing process with some idea about how it has evolved. So, you get to know relate to that concept to what has actually been done in the case of one chemical. So, that is what we are going to do in this. To recap technology development, I said the key points are that it is always with reference to an existing technology. I mean, we are not talking about something which is absolutely an abstract. So, it is always the existing is underlined, because it is better to know we are developing the technology as compared to what. So, this is very very important essentially. Second is why are we developing also should be very clear in mind. There must be at the back of the mind at least some application purpose in mind. This is the again the contrast between just doing research and doing research for some final objective. So, technology development, 2 points that you have to keep in mind is it is always in comparison to what is existing, one. Secondly, in order to meet some customers requirement. So, these 2 points should always be at the back of the mind when you talk about anything else. Second is this is a setup process, it is not one unique thing. A technology is not just one unique thing which is a you will find it is a interconnecting of lot of ideas all woven together. So, it is a sequence of steps, number of steps which is seen in terms of a flow diagram, P and I, mass balance essentially. So, that we know by doing this in this particular way as compared to something else which existed in the past, what is the specific improvement that is happening and why is it happening. It is not sufficient to say a claim that this is better, but you also know technically why is it better, is it tenable, is it reasonably possible. And of course, this means that the starting point is a lot of basic science. You really have to be kind of understanding what the basic science is all about and how it is applied in a given situation. Okay. So, that is the technology development. The logic once again is first you have to start with an existing method. So, if you are trying to develop a technology improvement, first go through what is already available, this is a very essential step. So, you have to study the existing process fully end to end. In that process you will spot some opportunities for improvement, especially if you know how the technology is serving some end customers requirements. If you keep the customers requirements also at the back and you study, for a person who is experienced familiar, he would come to know of some potential spots which are open for further improvements. That is how identification of second step. Third is before you jump in and say okay, there is a potential improvement over the existing process and I will start working on it, because it is time consuming, we saw, always best to go and do the patent search. This is an important step, because usually in academia this step is ignored. We do first one and second one probably, you study an existing research paper, whoever has done that, then you find there is an opportunity after the first 2 steps are clear. The third step is we will simply go and start planning our work. Here there is an additional step is you go, because it is a commercial world, finally some end user we are talking about, you go and do a search of the patent literature. It is not always possible for one person to do this research, because it is an expert area. So, you hire some expertise there and get to know what has already been covered up to what point of time, and in spite of that if there is a working way for you to work your way around. Usually it is, in spite of the 6 million patents available, you will always, and in spite of the fact that most of the patent lawyers try to cover everything, you still find there is some possibilities. That is that step. Now, the real thing is think of that opportunity and come out with an interesting idea that you have, which is likely to result in an improvement. That is the fourth step. But you have to test it out, because this is only an idea, it is in your mind, you have to really see whether it actually works in practice or not. So, you have to test it out in some small whatever facilities that you have got. Obviously, it will be in a lab scale, or if you are a bench scale or something like that, to test it out. At the end of it, now you have to scale it up and do some actual measurements, preferably in a pilot plant kind of a thing, so that you get some interacting, because it's always not one thing, it is an interacting thing. So, in a pilot plant it gives you an opportunity of creating that interacting things and collect, obtain data. Now, you are ready to actually build a plant and offer the first version to a customer who is willing to try it out. Obviously, from the customer side, if you look at it, he will say, what have you got? I have got a new technology. Then he will say, but I mean, what is the need? I am happy as it is, because people are already using something there. Then you will be able to sort of argue your case as to why your things are superior and so on like that. With this funda, now we are going to actually take out one technology, which is I have written down here as caustic soda making. Caustic soda making is from several things. The technology of membrane based caustic soda, I am going to briefly say how it was handled in real life in practice. Why caustic soda? First of all, why this example is the last reason is the best reason, because I am very familiar with this, I can talk about it. Leaving that apart, caustic soda is a very important chemical, a very large chemical used in a variety of applications, which means there are a lot of potential customers for you. Right. It is not a very niche product where market is very limited, it is a huge number of users across, I mean you can think of. So, it is worthwhile to know how people have gone ahead for a very large application area. Second is, this is one of those few cases where Indian chemical companies can also compete. It is not always the case, but in this case it is possible. Third is, in some way this caustic technology is intricately linked up to this green hydrogen. We will find out all that. So, for the reasons I thought that we will take this membrane technology, caustic soda making. Essentially what this process is, like you say, the logic is you have to take an existing one, study it fully, look for potential opportunities, come out with the idea. So, with that, first of all, what is it? Is there are several ways, but I will start with the electrolysis way. The electrolysis process of common salt is the most common thing. You take a salt solution, common salt solution, electrolyze it, you get caustic soda. So, that is what it is in principle. Though it was not the case, I am taking membrane. So, I take one step back, which is also an electrolysis process, but if you really take one more step back and one more step back, you will write from the time when caustic soda was discovered and then how it was made use of. It is a very interesting study. In fact, there is a very nice book written about the origins going back to the BC days of Egyptian civilization, how they at least knew how to use caustic soda. They might not have known what it is, but they used it and how they generated all that. So, it is a kind of a moving thing. I am starting from membrane. So, one step back membrane is also an electrolysis process, okay, from there. So, that is the existing technology. So, what is this existing technology? This was called mercury cell process. We are going to talk about membrane, but I just went back one step for the logic of knowing what is the existing one. At that time, what was existing was mercury cell. This is again an electrolytic process. It was a very reliable plant. It was working. Plant capacities were in the order of 100 to 300 tons per day, which is a reasonable size. So, they were existing at several parts of the world. People were working and it was producing the product and so on like that. And that technology itself has been slowly improving over 30-40 years. So, there was no doubt in anybody's mind at that point of time that this mercury cell process of making caustic soda works. It is a proven thing. So, that was the background. I have given two indicators of to get a snapshot of the technology. What it practically means is the two things. One is, when you say electrolysis, obviously it uses electricity for carrying out the manufacturing. So, the electricity consumption per unit of the finished product is an important criteria, right. So, that gives you some idea about the variable cost and so on like that. So, one indication is what is the power consumed per unit of caustic soda. I have given the figure here. It was some plants which is slightly more efficiently operated probably will be 3100, something which is not so well operated maybe 3200, but in the range of 3200 have been operating there. The product quality is you get caustic soda with 50% concentration. Why not 70% concentration is beyond 50% it tends to become very close to the point of solids crystallizing out. So, if you have to make that caustic soda as solution and then transport it for the end users. Like I said, there are so many end users. You want to avoid the risk of in transportation things crystallizing out and plugging. So, 50 is just about concentrated enough so that you do not transport water instead of caustic soda. At the same time, it is not so bad that you have a product handling problem. So, that is 50%. And since it is made from salt, you should not have remnants of raw material carrying along with it, right. So, it should be as pure as possible. So, this was meeting the requirement in terms of very low salt content, purity of salt. So, that was the existing technology. Now, we are going to take a little deeper look at it to say study it in order to spot opportunities. The process takes place, it is an electrolysis process, it takes place in something called number of cells. Cell in this definition is not biological cell, it is a cell is a repeating unit. So, it has got an anode and a cathode at a minimum and an electrolyte, where the chemical reaction inside the cell will take place. So, that is what it is. Here is a nice flow diagram, this is very interesting. So, we can it is still not a flow diagram, I must tell you, it is only a sketch, but flow diagram is horrendous. I tried copying it from a well known source, but then the whole picture became blurred. So, with that small cheat code, we will consider this nearest substitute for a flow diagram, but in reality you have to take the flow diagram to study it. Okay. So, this is the cell, a single cell, where you will find that there is one dark line, this line, you can see this one here. So, that is one electrode and the body itself is the second electrode. As you can see, one is connected to one polarity, the second one is connected to second polarity. Now, basic chemistry we say this anode cathode confusion, I think mostly people can't recollect. Easy way to remember is follow the electrons. If the electrons is coming out from somewhere, it is called anode. If the electrons are going into somewhere, it is called cathode. So, in this case, if you say this is the negative electrode, so we presume that the electrons are going to go into this. So, this is the cathode and the electrons from the process are picked up and it is going to come here. So, that is the anode, two plates together, and what comes out here is there is saturated brine, which means concentrated salt solution. There is a lot of process ahead of that in terms of starting from common salt, which is just common salt, then you do a lot of pre-treatment to that. Later on I will come back and say why that pre-treatment, but today we will assume for this concentrating on the cell, which is the most important thing. You get this as saturated solution as possible, this comes into it, of course there it brings in water also along with that. It flows past and goes out as a depleted brine. So, that is this flow, and the entire thing itself is slightly sloping. So, you would have noticed it slightly kept slope for a reason, and it is covered at the top, and because chlorine gas is going to be evolved, we will see that. So, it has to be kind of enclosed. So, it is covered and then gases are coming out from here and the reactions are shown here, anode and cathode reactions. The idea is supposed to be in this process, the sodium chloride which is in water existing as Na plus and Cl minus, Na plus drifts towards the cathode and very close to the cathode, electron jumps from the cathode to the solution and Na forms, and instantly that Na gets into the mercury. Actually, it is a oversimplified picture. The really thing that happens is very close to the mercury layer, when the sodium comes, one does not quite know exactly what happens, excepting next instant sodium is inside the metal. So, that is what that happens. So, sodium is picked up by the metal consuming one electron, and since it completely dissolves in mercury, it flows down along with mercury because of gravity, out it goes. So, we have lost one Na plus by giving one electron. Now, but this electron has to be made up somewhere. Simultaneously at the other electrode, what happens is chloride ions which are going very close to the electrode loses one electron to the electrode and becomes adsorbed. Then the second chlorine atom similarly has a journey, they combine together to form chloride gas, they dislodge from the surface, and out it goes bubbling through the layer. Now, mercury first why is it chosen? By the time this process was 40-50 years. So, somebody had a why mercury of all places, one we said it is a metal electrode, the other why mercury was chosen for two reasons is it was found arising out of a large number of experimentations, observations. First of all, mercury makes an amalgam of sodium. Mercury is not wettable, this is a very important point, it does not get wet with water, and in that way the moment Na plus from aqueous solution becomes Na, it should not see water, because if that is the case the electron of that Na can jump to water and again Na plus will get. In fact, all of us from elementary school chemistry we say if you take a metal small piece of sodium and put it into water with an explosive violence that reacts and hydrogen gets liberated and all that. Here is a funny case where it is a brine solution NaCl, lot of water is present. In spite of that, because of the non-wetting property of mercury, when it comes very close there is an electron jumps into sodium and instantly sodium is also inside the metal, therefore, the chances of exposure back again is. So, that is how people have sort of picked that idea and technology was converted into this particular piece of equipment, making use of the all the facts from there. On the other hand, chlorine is in contact with NaCl solution as Cl minus ion. So, the moment it forms Cl and then Cl2, it has to bubble through the solution and go out. Now, some amount of chlorine will also dissolve in water, obviously the chlorine will to the solubility limit will get dissolved to the water. So, this is the setup. Now, we have got mercury coming out of that, luckily we have avoided Na plus going back into solution again. So, we picked it up, came out, but we were interested in caustic soda. So, in a separate piece of equipment what you do, you take that, you can see from here water, pure water, because that water relates to the caustic soda's own product specification, plus you do not want any other impurity finally to go into the react. So, you add water into that. In this case, because water and this is a different piece of equipment, unlike here there is a thin flow without film getting disturbed, mercury should go. Here you violently make conditions that the droplet to droplet they react. So, reaction between sodium and water takes place, it becomes Na plus again, OH minus, electron picked up there and hydrogen is pushed out. So, hydrogen gets liberated as a separate gas here, it is a separate piece of equipment. By adjusting the flow rate of mercury sodium amalgam and water, you can adjust the concentration of caustic that we produce. So, that is the part. Now, after this, now the mercury has been stripped of sodium, it makes its journey back again to the electrolyzer by a pumping system. Now, one part of it is under potential because electrolysis has to take place, the other part should not be. So, there is lot of little things like insulator, how do you in a pipeline one part should be conducting, one part should not be conducting is a matter of detail, all of us can do. If you know sufficient think about insulation, cleverly you can install it. So, that is the principle of this. The funda that went into chemical engineering into this was chemistry is very clear, NaCl, arrow, electricity, NaOH, half Cl2. The chemical engineering part was first what is the film thickness of mercury. If it is too thick, what would happen you can make out is that of course, it will still conduct, it will pick up electron, that is not a problem, but if it is thick enough, the number of electrons that are transferred per meter cube of mercury, if you take that, will be low, because quite a lot of it is flowing through, only a few of them will pick up and transfer. So, the overall productivity of the production will come down. So, you must make it as thin, preferably a monolayer if you can escape from that, but if you make it too thin, so that there are pockets of mercury and pockets of water, then you have a problem on your hand, because that water will immediately react, like this situation will get repeated there. So, there was a first of all those days, I think I am talking about 1930s 40s, computers were not discovered. So, people took their Navier-Stokes equation by hand, do difference method of solving that, try to figure out should it be 10 mm, 5 mm, 6 mm, 8 mm, and after that initial calculations experimented it with respect to this theta slope is an important. Some of you would remember from Bird, Stewart and Lightfoot, there is a famous thing, you have one inclined plate, in which a thin film of water will flow through, you will find the delta thickness and then mass transfer coefficient, all that is. This thing was done, excepting lot of parameters you would not know, but you will get a feel of what it is, get some, and then you will repeat it in a plant. That is how this 40-50 years of thing has taken place. That is one aspect of that. Second aspect is same thing to switch to the other electrode. This electrode is dipping inside an aqueous solution and getting chlorine, and wet chlorine is highly corrosive. If the chlorine is dry, at least for metals it is not as corrosive. For human beings, because of the mucous membrane, everything has got water, that is how the chlorine, wet chlorine is too bad. So, this is wet chlorine. So, one had to find out what is the metal that will conduct, but will be still not be corroded away in the process of conducting electron. After a lot of trial and error, people first they started with carbon, because easiest thing is no, it is carbon conducts, everybody knows. So, graphite electrodes were made, then the graphite has to be made into a plate. So, you have to have a binder. Over a period of time, this chlorine ate up all the binders and this collapsed. So, one after the other, one after that, finally people went into titanium based electrodes. So, that is how this was. Now, this is a quick summary shot of existing mercury based process. Now, go back and see all this hard work has been done by somebody. We can now scale it up to make 300 tons, 100 tons equivalent, which means the depth of immersion, width, angle of inclination, pump around rate of mercury, the diameter of this vessel, everything was kind of initial from first principles assumptions, then actually experimentally setting it up, checking, scaling up was ready, plants were built, first plant was probably had some goof ups and so on like that. So, this is what honky dory, everything is nice and happy, things are going on. Why there is a new process required? Now, by the way, we did the quick of running through the existing process in some detail we have done. Can somebody spot opportunity? Because we are supposed to, for technology development, think of study existing one, but at the back of the mind you should keep some end user in mind, okay? Because in abstract you cannot think of an improvement, you have to think of some end user. So, we are thinking of who are all these guys who are buying caustic soda and so on like that. And now, anybody can spot, you will hit a jackpot if you did. I could not when I was a student. So, I am asking you, can you see some improvement? Some numbers I have given you, 3100 units of power used per kg of caustic produced. Keep thinking. Key components I think I have gone through: anode, cathode, electrolyte. Now, some basics on to this. There are two things. As I gave a clue, 3100, somebody must saying, 3100 is a lot of power, right? 1 kilo of caustic soda to make 3100 seems to be too much. Is there anything that can be done to sort of reduce it? Because the whole life, like I said, is reducing the cost. What is the cost of making stuff? What is the cost of making plant that makes stuff? So, these are the two things. So, the first thing that might come, obvious thing is, everything is fine, okay, but if I have come out with something which will reduce the energy consumption, for example, I am likely to be better off. So, in order to know why this existing process consumes 3100, we have to get into detail. Okay. Basics of thermodynamics is required. Some of you are familiar with Nernst equation, all of you must have gone through, right, which says if you take a metal and dip it into a solution of containing some ions, there is a potential that develops between the two. You can't measure it, because we are talking about a single electrode dipping inside some electrolyte. Think of anything, copper, put it into salt, iron, take it and put it into some other solution. There is a potential that will go through. Fundamentally, if you take it back to why is it so, is that it is all our great electrons playing the joke. The electrons which is sitting inside the metal is at some Fermi level, but inside a solution there are ions, which means there is also electronic orbitals of these ions hanging around. So, you have got an electron which can choose to reside in the metal at certain energy level. It also now finds at least very close to the electrode lot of other orbitals where it can occupy. How they reach an equilibrium is Nernst equation related to the activity and therefore to the concentration. The whole thing is finally it comes down to thermodynamics of at steady state the delta G is 0, because that is the fundamental of life. All processes are in equilibrium when the free energy change is 0, and if the free energy change can be negative, they tend to follow the reaction. If the free energy change is positive, you can't have that reaction happen unless you couple it with another reaction whose delta G is much lower than this. So, from there you can, now what I am trying to drive it, you can get to know the potential between caustic soda. In order for that reaction to take place, we have to apply an electricity, and that application of electricity requires some voltage. Is there some idea that what is the absolute minimum voltage that I have to have below which the reaction will not play? Thermodynamics gives you that kind of a thing, take a reaction for instance, what is the absolute best equilibrium conversion that you will have at a certain temperature and conditions. You do not have to do an experiment, but you can get a good guess of what it is. So, Nernst equation. The second is equivalent to kinetics. I now got an idea that at equilibrium conditions, which means no current flows, but you want a device where the current has to flow for practical use. So, but first you start with some idealization that 100% reversible if it took place, which means there is hardly anything happening, that is absolute minimum voltage driving force required. You will get some idea. Second is, in practical terms you want as much current to flow so that you get production out of it. That comes from how fast the electron transfer will take place between a metal surface and the ions which are close to the metal. This is very different from our kinetics, where we talk about a rate of reaction depends on the concentration and you get this K and so on. Here it is an equivalent to K, but that is not concentration dependent, it is dependent on the fundamental properties of the metal. So, that comes from Bolter. Anybody who had done electrochemistry will know, but take it for granted it is like equivalent to a kinetic equation. So, with these two if we went through, then we will know. That is how first I have written here from thermodynamics that this reaction what was taking place in the mercury cell, Na plus from solution went very close to the mercury and one electron was taken up, it became Na. That thermodynamic potential will be this under standard conditions. This is just about the minimum driving force, below this you will not have very clear. Now, come to the second electrode, similar reaction I have put in there. Now, total up you get this reaction of NaCl splitting into Na and Cl, voltage is 4.1. So, which means you cannot have a mercury cell which operates at anything less than 4 volts and still hope that there will be production. So, we have got one good by just studying the process. Now, convert it into, all this is starting from where the need is I have to think of a process compared to mercury cell in order to have a benefit for the customer. So, if you go back to that logic and then convert this 4.12 volts into energy consumption, second make use of this Faraday's laws of electrolysis, where 96 Faraday is 96,500 I have taken for it here. 1 Faraday of electricity when it passes through a solution, theoretically 1 equivalent of material will get deposited. So, that you know. So, if you know that and if you know that that transfer will require a minimum of this voltage. So, you know the delta voltage, you know the charge that has to go through per equivalent, then voltage multiplied by the current is the power required for that equivalent you will know. It is now you have got what is the energy consumed in this. Calculations are here, I am going to post it, you can go through, but do this calculation. It is simple calculation, no great concept, you just have to be patient, make consistent unit, you will get 3160. So, this is how it is. Now, with this in mind, what is the motivation? So, one motivation is probably we are looking for saying that is there any other way I carry out the electrolysis reaction, so that the energy consumption can be reduced. So, this is can be one motivation of that. As it was happening, a lot of work was taking place, it all went back to saying that just now we said 4.1 volt is the kind of a theoretical minimum, how in world somebody can get less than that will be the question. That is because the theoretical voltage depends on the actual self reaction that to take place, and the cell reaction was sodium going into sodium ion going into mercury amalgam was the reaction, at least one half of the reaction. Okay. If you are able to break that, which means is there any other electrode non mercury which will allow this reaction to take place at a lower potential, then you have got a good thing going. Logic is very clear. So, you are one possibility to look for saying that we got this energy because mercury, and mercury is required because it is a beautiful thing, it works, it picks up electron, transfers to sodium without mess up on water, it can be separated, it flows also very nicely. So, you have a continuously recharging kind of a electrode to carry out the reaction, all that was 30-40 years of work. But now you are asking your question, for the price that you paid is in terms of energy consumption it is very high. Can we now think of some clever way of another way of doing this electron transfer? That is what it is. So, this was going on. Another thing that happened, sometimes it is events in life just take place and that can be a catalyst. In this case what happened, there was a small fishing hamlet called Minamata, read up, Google this. This is a place where suddenly it was discovered in the community there were large number of neurological problems among population. People are reporting very peculiar. Usually such things are a manifestation if you are affected by mercury build up inside your body, this happens, and they actually found this population had very high unacceptable levels of mercury inside their body. Now, as it turned out, the root cause of that mercury coming was a plant which was making acetaldehyde, not caustic soda, and that acetaldehyde process required mercury Hg2 plus ions to be a catalyst, because sometimes liquid homogeneous catalyst you add some catalyst. So, mercury 2 plus ions were catalyst for making acetaldehyde, and at the end of the process something effluent was let out, and that effluent was going to the sea, and in the sea fish ate, and that mercury ion can get stuck in your cells as methyl mercury Hg2 plus na. So, it is looking for electrons in your body, there are hundreds of places. So, it gets converted to methyl mercury, that is a very stable compound, remains in the body. So, when this happened and it became a national disaster, anything to do with mercury became suspicious, even though Minamata was not caused because of problems of mercury from the caustic soda plant. Actually, if you look at the process flow again, there is nowhere mercury plus is coming. After all, metal mercury flows, it gives one electron. Okay, there is a possibility at that time you can say that Hg lost that electron, it could have become Hg plus, no, but it was always connected to a power source because the electron was instantly made up. So, nowhere there is mercury plus was possible, but in a situation like this people will not go all this scientifically and say this mercury is okay, that mercury became a major disaster. So, that was a push suddenly that came. So, we were looking for anything to do with mercury, we should get rid of it, and here is nice caustic soda plant all over the place using mercury on that. Third set of fortunate event that took place more or less, which is during this happened during the 1960s. So, Minamata is all getting published, newspaper, research reports, parliamentary committees, all that works is taking place. Parallelly, they deep down the research on fundamentally what is the electrochemical processes which can reduce the voltage is also happening. Third development that took place is energy prices sharply went up. Some of you, you are all too young because you are all 1990, 2000. That is the time we were growing up. The first war, Gulf War took place. Gulf was a major source of oil and gas for many years now. So, there was a major conflagration of a fight between Israel and the Arabs. So, that means all the Arab countries decided to push an oil embargo. Oil which was being sold to, I remember it particularly, $1.5 to $2 per barrel, $1.5 to $2 per barrel went up to 70 in those days, and in US there were rationing of petrol and people were standing in it. So, there is a major event in life. So, energy cost went up. So, when the energy cost went up, for everybody energy price will go up. What happens to electricity prices? They also went up. Now, we have got three forces acting. Somebody is looking 3160 units of power per kg of caustic. No, now the caustic prices are going to go through the roof and my market may collapse. So, there is one strong motivation for reducing the energy consumption in real terms. There is also a pressure from the society and the government that you should phase out mercury. If possible, tomorrow stop all mercury plants, but nobody could stop because then the whole economy will collapse. But there is a pressure that when will you get out of that was happening. Parallel to that is of course, the research is also taking place. So, these are the three things that made. Here is somebody who there are so many fortunate events that took place. It was found that the problem is you are wanting to have Na plus become Na, that was a catch. What if we kept Na plus, because the logic is what you are trying to make, you are trying to make caustic soda. What is caustic soda? NaOH. NaOH is Na plus OH minus. You have got salt which is Na plus Cl minus. So, here is Na plus Cl minus, you want Na plus OH minus. Why are we making Na plus into Na and Na back again to Na plus? Go back to the flow diagram. This and this you are making it because we did not want everything to happen inside this, because if it happened here, what would happen is hydrogen will also start liberating here, right. Actually, what will happen is when Na contacts water, it will produce OH minus ions, hydrogen will come out. This chlorine and hydrogen will get mixed up and that is an explosive gas. So, in order to overcome that, these two steps very nicely electron. What if you did not want Na to be converted to Na plus to be Na, keep it there, but do not allow mix up of hydrogen and chlorine. Sounds crazy? Look at the same electrolysis. No, I am going to get rid of mercury. That means hydrogen is going to come in the cell, but I will make sure that chlorine and hydrogen do not mix with each other. That is the membrane. So, it was discovered, it was not related to somebody wanted to develop a membrane caustic soda, it did not happen like that. This is the trick between, I said research and development and ideas are going all over the place everywhere, and intelligent good companies are watching, waiting to see what is happening everywhere, and the right time what applies to their business they will pick up exactly the same thing. Membranes were being developed for the heck of getting membranes. How many? Right from the time when polymers were discovered, people have been just trying to create membranes for their own reasons. One such membrane turned out has to have a property, that means it will preferentially pass only OH minus ions either way. If you take a solution, put a membrane in between, and on both sides of the membrane you have got ions, only the OH ions it is permeable, none of them will pass through. So, this membrane was developed, we get hold of the membrane. Second is, it was also turned out that with some tweaking it could be made stable in alkaline media. One is it can pass through OH minus, all right, after some time the OH minus slowly reacts and the whole membrane collapses, means there is no need. It is also stable, and if it is exposed by chance to chlorine also it is stable. So, that is the second. The flip side was it was very sensitive. Now, why it is only OH minus, I will not get into that, because that is basic science. You really have to know a lot of organic chemistry, a little bit of quantum chemistry to know what a membrane, why it suddenly became only selective to pass. It is not the pore size, definitely that is not the case, it is not a physical thing that the OH minus ion is like this, so therefore only it will pass through, the rest of the bigger things will not. It is not a physical thing, it is something to do with a chemical process. So, on the other hand, if there were bivalent atoms like calcium plus, magnesium plus, aluminum 3 plus, this movement was problem, because you can make out when the OH minus ion is trying to go through the chemical process, if there is calcium or magnesium or aluminum, calcium hydroxide, magnesium hydroxide, aluminum hydroxide solids will precipitate, that is the end of the story of the transmission process. Another interesting, all this did not happen on a single day, by the way. Some group was working on OH minus, another group will be working on this, it is a kind of a ecosystem. Chemical engineering part of you, somebody felt okay, all this fancy membrane is fine, can it be made in sufficient quantity, can you make that membrane? processing techniques were developed to make it into a thin strong films. Now, we are back to this process, cell to cell only I will show. Here what you do is that you take a cell, which means some container contains salt solution. Let us get this great membrane and insert it and make it into two halves, one half and the other half. What we do is that on this side, on the left 540, normally I should be closing in another 5 minutes. If I go to 550, is it okay? Otherwise I can continue in the next class. Only this slide I will probably complete it, then we will see. So, on this side of the membrane, what you do, you put salt solution, purified salt solution. There also there was a purified salt was coming in, concentrated brine. Here also it is, you can see saturated brine, purified comes and fills up on this part. So, it has got Na plus Cl minus water. On this side, take some dilute caustic soda. Actually you need only water, but we are adding dilute caustic soda, the reason will be clear in a minute. So, you put that into that. So, membrane, what would happen is Na plus cannot pass through the membrane, Cl minus cannot pass through the membrane, OH minus which is on this side of the membrane can pass through the other side, keep that in mind. Now, what we do, we put one anode, cathode, connect the potential to that. In that case what happens is, this is a negative electrode. So, the Na plus ions will which are here as NaCl will come across and chlorine will go out, OH remains OH. So, what happens is internally hydrogen generation takes place, that hydrogen goes out, this membrane also separates the chlorine and hydrogen to that. Okay. So, we are combined both into a single thanks to the property of the membrane. Because of this what happens, why is the energy semi lower? If you now go through the again Nernst equation, in this case the two reactions are Cl minus becoming Cl is one reaction, that is not changed. The other side is what happens is you need something to absorb the electrons, right. In the earlier case Na plus through mercury was here, water absorbs electrons and becomes OH minus, releases hydrogen, hydrogen gets out. So, the hydrogen generation reaction if it takes place in the same membrane, the potential for hydrogen all of us know standard potential is 0. You recall that all the electrochemical potential standard is H becomes H plus is taken as 0. We do not know what the potential is, to be honest, very honest. Convention is you need a reference point, we take it as 0, all others are with respect to that, with the view that 4.1 volt drops down to something like 2.1. No doubt energy consumption comes crashing down. So, that is the reason this process has a potential of reducing the electricity consumption from that number of 3200 to something like 2200. There are some minor actually power increases, because the brine has to be ultra pure, because the membrane is bit sensitive for that. So, there is some energy consumption that you spend on that and all. The caustic soda that you produce in the earlier case, by controlling just the water and the mercury fluoride, you can get up to 50%, which is close to saturation. Here it is a bit hard to get it, and therefore, you will end up with 43-44%, and in order to go back to the customer specifications of 50, you have to put an evaporator and evaporate it, normal double effect evaporators. So, you spend some energy there. Netting of these two, still it turns out to be a big energy savings. So, with that in mind, go back and say what is this process is supposed to be in response to problem number 1 from the customer side was, if you have a mercury based plant, or if you are wanting to set up caustic soda manufacturing for making business, mercury is going to be phased out. Here is the solution. Second, energy prices are going through the sky, and therefore, if the cost of making caustic soda can be brought down, you are in business. This brought down, it took off. Now, practically world over, almost all mercury soda plants are phased out. Poor guys, for no fault of theirs, they never contributed to mercury pollution anyway, but economics took over. I am now wondering if it was a situation where there was energy prices did not increase, they continue to be at $2. all this Mercury tamasha would have taken place. Oh, after some time probably people will get some other problem, some earthquake in Iran or joint parliamentary committee, mind will get diverted, who will care. It so happened that the economic driving force just matched. So, many of you, going back to the assignment which you submitted, this 500 ppm of SO2 I think put off everybody. You are all wanting to put a scrubber. If you read that assignment very clearly, the 500 was put to say sulfur dioxide is present. Nowhere it said that 500 ppm is not allowed. But I think all of you these days, younger generation is so much attuned to environment, whether it is stated or not stated, SO2 that shall not be there SO2, and we got off with a solution there. Here is a case where economics really, and this is true of life, almost invariably economics will happen. What might happen is, what is today not economical might become economical due to circumstances after some period of time. But I have not seen a single case where forsake economics and get into only in a large scale. iPhone buyers maybe, because iPhone is buy at a higher cost because you like an iPhone, right, but not everybody. So, mass market still is decided. So, today's I will stop here with this slide. Today's scenario is a number of companies are offering this technology. Here I want to ask you, what is technology in this? It is called membrane based technology, but is there a single technology? Membrane synthesis is one. The caustic soda companies did not synthesize, and such membranes have got multivariate applications in so many other places, which we can in a later class. So, one development of membranes with some property was going on, other development of how to reduce energy consumption was going on. It is a clever, going back to my first slide, all these clever ideas put together in a sequence of arrangements in terms of nicely designed equipment, that combination is technology. So, it is very hard for somebody, keep that in mind, I am going to develop technology, does not normally work out like that. You might be interested to develop a technology, that is a different matter, but for a given application you should keep it in mind, which means basically which end user you are keeping in mind and what features which will give you that additional benefit to the customer can be from 3, 4, 5 places. Your ability to integrate all of them in terms of a process flow diagram, paint diagram, basic engineering equipments, that combination is what is technology. So, technology is not one single thing which just comes like a wave and the whole thing gets transformed. Even if you take our digital revolution, it is not one single thing. Somebody must have developed a computer chip. If that was not the case, rest of them goes. Somebody must have come out with a wireless technology. That did not happen, this would not happen. Somebody would have written a software called Internet Protocol. If that did not happen, this did not happen. So, a lot of interacting factors, if they join together, that is technology. So, that is what we will do. We will continue in the next class, just couple of more slides tomorrow, just ending basically. But tomorrow what I am going to talk about is your assignment. This is a critical assignment because it has a big weightage. Remember, we talked about a project work. So, I am going to spend whole time tomorrow's class detailing out what we can do, so that it has to be interactive. You have to decide finally and tell me what you are comfortable with. Accordingly, we will freeze on what is the project work, methodology, how do we do, what is the time frame, etc. Tomorrow we will discuss.